Now we'll discuss UGB paper. Now it says let ABC be real numbers greater than 1 and let S denote the sum. S equals log BC base A plus log CA base B plus log AB base C. Now log M into N is log M plus log N. So we can write this as log B base A plus log C base A plus log C base B plus log A base B and then plus log A base C plus log B base C. Now since all these numbers they are greater than 1, all these numbers they are positive numbers, and if numbers are positive we can use AM and GM. So if we take their arithmetic mean will be log B base A plus log C base A plus log C base B plus log A base B plus log A base C plus log B base C upon 6. It will be greater than or equal to log B base A into log C base A into log C base B into log A base B into log A base C into log B base C to the power 1 by 6. Now we know that log B base A into log A base B, it is 1. So this log B base A and log A base B, this value it is 1. In the same way, log C base A and log A base C will be 1, and this log C base B into log B base C will also be 1. So this right hand side it is 1. So we can write this S, it is greater than or equal to, we'll take this 6 on the right hand side, so it will be greater than or equal to 6. So the smallest possible value of S will be simply 6. Now here the question is, for x greater than or equal to 0, we have defined fx as 1 upon x plus 2 cos x. Now we have to determine the range of this function when x is greater than or equal to 0. Now if we find f dash x will be minus 1 upon x plus 2 cos x whole square into 1 minus 2 sin x, it is equal to 0. That is when the value of sin x is 1 by 2. Now value of sin x is 1 by 2 when the value of x is n pi plus minus 1 to the power n into pi by 6. So if we take the values from 0 to 2 pi, it will be 1 by 2 at pi by 6 and at 5 pi by 6. Now this is negative, it is positive, it is negative. So if we find value at 0, f0, it will be simply 1 by 2 f pi by 6. F pi by 6 will be 1 upon pi by 6 plus cos pi by 6, and cos pi by 6 is simply root 3 f 5 pi by 6. F 5 pi by 6 will be 1 upon 5 pi by 6 minus root 3, which will be 6 upon 5 pi minus 6 root 3. So if we draw an approximate graph at 0, this value is 1 by 2, and then this function it decreases to 1 upon pi by 6 plus root 3, and then at 5 pi by 6 it increases to 6 upon 5 pi minus 6 root 3, which is nearly 1.13. So we'll take this value 1.13, and thereafter it will again decrease. Now this value will keep oscillating, and when x tends to infinite, value of this function will be simply 0. Now since it is a continuous function, it will take all the values between 0 and 6 upon 5 pi minus 6 root 3. Now there will be other points of maximas and minimas. Say for example 2 pi plus pi by 6 and 2 pi plus 5 pi by 6. But for all those points, as the value of x increases, this maximum value, it will be less than this 6 upon 5 pi minus 6 root 3. So this value is absolute maximum value. Therefore, range of this function will be from 0 to 6 upon 5 pi minus 6 root 3, 0 not included, and 6 upon 5 pi minus 6 root 3 included. Now question number 3 is, let this function f be defined from R to R such that mod of f x plus y minus f x minus y is always less than or equal to y square. Now we need to show that fx is x by 2 plus c, where c is a constant. Now what we'll do is, we'll try and rearrange this functional equation. So we'll let this x plus y as some t plus h and x minus y as t. Now we subtract the second from first, we'll get y as h by 2. So we can write this as mod of f t plus h minus ft minus h by 2, and will be less than or equal to h square by 4. Now mod x is less than a, then x lies between minus a and plus a. So we can write minus h square by 4. It is less than or equal to f t plus h minus ft minus h by 2, and will be less than or equal to h square by 4. Now we'll add h by 2. So we can add h by 2 minus h square by 4 will be less than f t plus h minus ft, and will be h by 2 minus h square by 4. Now we'll divide everything with h, and we'll take this limit h tends to 0. Now this value, it is 1 by 2. Now this is nothing but this is f dash t, and this limit, it is also 1 by 2. So from here we can say this f dash t, it is 1 by 2. Now we integrate this function, we write ft as 1 by 2 plus c, or we can write this function fx will be simply x by 2 plus c, where c is a constant. And this is how we solve such questions. Now question number 4 is, in a badminton singles tournament, each player played against all the other exactly once, and each game had a winner. After all the games, each player listed the names of all the players she defeated, as well as the names of all the players defeated by the players defeated by her. For instance, if A defeats B and B defeats C, then in the list of A, both B and C, they'll be included. Now we have to prove that at least one player listed the name of all other players. Now we'll prove this question using contradiction. So what we'll assume is, let no player has the names of all other players in her list. Now suppose players are P1, P2, P3 and Pn. Now if no player has the name of all players in her list, then there'll be some player who will have maximum number of names in the list. And let us say that player is P1. So let P1 has maximum names in the list. Now this P1, it has maximum names, but it doesn't have all the names. Now suppose Pn is not included in the list of P1. So P1, it has players, say P2, P3 and Pk, but it doesn't have Pn. Now since Pn, it is not included in the list of P1, then this Pn, it is undefeated by P1, and then it is also undefeated by any player in the list of P1. So that means Pn has more names in the list than P1, which is a contradiction. That means from contradiction we can say that at least one player listed the name of all other players. Now question number 5 is, let AD be a diameter of a circle of radius r and let BC be the points on semicircle such that AB equals BC equals r by 2. Determine the ratio of length of the chord CD to this radius. So we have this circle whose diameter is AD, radius is r, and then there are 2 points B and C such that AB is equal to BC. So this is AB and this is BC. Now this AB is r by 2 and this BC is also r by 2. We need to find ratio of length of the chord CD to the radius. Now suppose this angle is theta, this angle is also theta, and this angle will be pi minus 2 theta. Now this is r, and this is also r. Now in this triangle, say AOB, we can use cosine rule to find cos theta, and cos theta will be r square plus r square minus r by 2 whole square upon 2 r square. So it will be 2 minus 1 by 4 r square upon 2 r square. So this r square will cancel. So it will be 8 minus 1, 7 by 8. So value of cos theta is 7 by 8. Now if we use cosine rule in this triangle COD, we can write cos pi minus 2 theta, it will be r square plus r square minus CD square upon 2 r square. Now cos pi minus theta is minus cos theta, so it will be minus cos 2 theta, and minus cos 2 theta will be minus, and 2 cos square theta minus 1. So this value, it will be 1 minus CD square upon 2 r square, and it will be minus 2 cos square theta plus 1. So this 1 and 1 will cancel. So we can write CD upon r as 2 cos theta. Now cos theta is 7 by 8. So CD upon r will be simply 7 by 4. So ratio of length of the chord CD to this radius is simply 7:4. Now here the question is, let Px and Qx be distinct polynomials with real coefficients such that sum of the coefficients of each of polynomials equals s. That means P1 equals Q1 and it is equal to s. Now if Px cube minus Qx cube, it is Px cube minus Qx cube, then prove the following. And the first one is Px minus Qx equals x minus 1 to the power a Rx for some integer a greater than or equal to 1 and a polynomial Rx with R1 unequal to 0, and s square is 3 to the power a minus 1 where a is given in first expression. Now what we'll do is we'll write Hx as Px minus Qx. Now H1, it will be P1 minus q1, it is equal to 0. That means we can write this hx as px minus qx, and it will be x minus 1 into some function, say rx. Now we find h cube x will be p cube x minus q cube x minus 3 px qx into px minus qx. Now p cube x minus q cube x is px cube minus qx cube. So we can write h cube x as hx cube and then minus 3 px into qx into hx. Now if hx is a function having root 1 with multiplicity a, then we have to prove that h1 is 0, h dash 1 is 0, h double dash 1 is 0 up to a times. So what we'll do is we'll differentiate this function. Now we differentiate this function, we'll get 3 h square x into h dash x minus 3x square into h dash x cube minus 3 will be p dash qh p q dash h plus pq into h dash. Now we put x as 1, we'll get 3. Now h1 is 0, so it'll be 0. Now here it will be 3 h dash 1, and here it will be 3 h1, it will be 0, it will also be 0, and p1 is s and q1 is s, so it will be simply s square into h dash 1. So from here we'll get this condition that either h dash 1 is 0 or s square equals 1. Now if s square is equal to 1 and h dash 1 is unequal to 0, we can write this hx as x minus 1 into rx, and s square will be equal to 1. Now we consider this case when h dash 1 is 0. We'll differentiate this function again. We'll write 3 h square x into h double dash x plus 3 h dash x into 2hx into h dash x, and it'll be equal to 3x square h double dash x cube into 3x square plus 6x into h dash x cube, and here will be p double dash qh p dash q dash h p dash q h dash. Second one will be p dash q dash h p q double dash h and p q dash h dash, and then it will be p dash q h dash p q dash h dash and p q h double dash. Now again if we put x as 1, now h1 is 0, so it will be 0, h dash 1 is also 0, so it will also be 0. So on the left hand side we'll have this 0. Now here it will be 3 square into h double dash 1. Now since h1 is 0 and h dash 1 is 0, this is 0. All these expressions, they'll be 0 except this. So here will be minus 3, and p1 is s and q1 is s, so it will be simply s square into h double dash. So from here we'll get this condition that either h double dash 1 is 0 or s square equals 3. So from here we'll get this condition that either h double dash 1 will be 0 or s square it will be 3. Now if h double dash 1 it is unequal to 0, then in that case hx will be x minus 1 square into rx, where s square equals to 3. Now if we consider h double dash 1 as 0, now we have h1 equals h dash 1 equals double dash 1 equals 0. Then if we differentiate this expression again, then on the left hand side we'll always have h1 or h double dash 1, which is 0. So left hand side will be 0. On the right hand side we'll have 3x square into 3x square into 3x square into h triple dash x cube. Now all the other expressions will have h double dash 1, which is 0. So we'll discard all of them. And then here we'll have h dash 1 or h double dash 1, which again is 0. Now here too h1 or h dash 1 will be 0, except for this term, which will be minus 3 pq into h triple dash will be 0. Now if we put x as 1, we'll get 3 cube into h triple dash 1 minus 3 s square into h triple dash 1 equals 0. So from here we'll say either h triple dash 1 is 0 or s square is 3 square. So if h triple dash 1 is unequal to 0, we can write this hx as x minus 1 cube into rx, and this s square equals 3 square. So we get this recursive relation each time. So from this recursive relation we can say that this hx will be x minus 1 to the power a into rx, where s square is 3 to the power of a minus 1, and which is what we need to prove. Now here the question is, let n be a positive integer such that n into n minus 101 is a square of a positive integer, then determine all possible values of n. Now it says n into n minus 101 is square of some positive number, say m square. So we can write n square minus 101n minus m square, it is equal to 0. Now we can write this n as 101 plus minus under root of 101 square plus 4m square upon 2. Now since n is a positive integer, we'll take this plus sign here, and also it is an integer. That means this expression within the square root, which is 101 square plus 4m square, it must be perfect square of some integer, say k. So here k belongs to set of integers. Now we can write k square minus 4m square equals 101 square. Now we can write this as k plus 2m into k minus 2m, and L be equal to 101 square. Now this 101, it is a prime number. So the only way to factorize this 101 square is when we have k plus 2m as 101 square and then k minus 2m as 1. So if we add them, we'll get the value of k as 101 square plus 1 divided by 2. So now we can write this n as 101 plus k upon 2. Now this is 101 plus k is 101 square plus 1 upon 2, which is 101 square plus 2 into 101 plus 1 upon 4. Now this is a square plus b square plus 2ab. So this n will be simply n plus 1 whole square upon 4, or we can write this as 102 upon 2 whole square, which is 51 square. So the only possible value of n in this case is 51 square, and that is the answer to this question. Now here the question is, let ABCD be a square with side AB lying on the line y equals x plus 8. Suppose C and D lie on a parabola x square equals y. find the possible values of length of the side of this square. So we have this parabola x square equals y. And then we have this line which is y equals x plus 8. Now we have this square where AB, it lies on this line, and then we have CD. Now CD is parallel to AB, so let the equation of CD be y equals x plus c. Now this line, it will intersect parabola at 2 points C and D. So we'll find point of intersection of this line y equals x plus c, and then this parabola which is y equals x square. So we'll put y as x square, we'll write x square minus x minus c equals 0. Now this equation have two real roots. Say x1, so this is x1 comma x1 square, and here it is say x2 comma x2 square. Now sum of roots x1 plus x2 is 1, and product of roots x1 into x2 is minus c. Now we can find difference of roots also. So we find x2 minus x1 will be under root of x1 plus x2 whole square minus 4 x1 into x2. So it will be under root of 1 plus 4c. Now once we have x2 minus x1, we can find length of this side CD. So this CD, it will be under root of x2 minus x1 whole square plus x2 square minus x1 square whole square. Now this is a plus b into a minus b. So we can take x2 minus x1 common, and here it will be 1 plus x1 plus x2 whole square. Now x1 plus x2 is 1, so this value will be root 2, and x2 minus x1 is nothing but under root of 1 plus 4c. So length of the side CD, it is under root 2 under root 1 plus 4c. Now we can also find length of the side AC. Now AC is nothing but distance between these two parallel lines. So this AC, it will be mod of c minus 8 upon root 2. Now since this is a square, both the sides, they must be same. So we can write mod of c minus 8 by root 2. It must be equal to root 2 into under root of 1 plus 4c. Now we square it, we can write c square plus 64 minus 16c, and here will be 4 plus 16c, so it will be c square minus 32c plus 60 equals 0. So it will be 13 to 2. So value of c is either 2 or value of c is 30. Now we need to find length of this square. Now length of this square is mod of c minus 8 by root 2. So length of this side will be 2 minus 8 upon root 2. If c is 2, which is 6 upon root 2, that is 3 root 2, or this length of the side of the square will be 30 minus 8, 22 upon root 2, which is 11 root 2. So there are two answers possible. Either this length is 3 root 2 or it is 11 root 2.